Hi everyone, in this video my plan is to talk about transformation a bit, and most of our discussion will be related to quadratic transformation. So let's see how far we can go. Say a function f(x) equals to x squared. So what is the graph of this? Rough graph of this will be like this. This is the up opening parabola, this is x-axis, this is y-axis, then our graph is like this for this one. And then what about if we write f(x) equals to x squared plus, let's say 2, then what about the graph? So for this plus 2, the graph will go 2 unit up actually. So whole graph, the shape of the graph will remain same, just it will go 2 unit up. So this is 1, this is 2 for example, then our graph will go like this. So this will be our graph, this is our 2, this is 1, this is 2 for this 2. And if I write f(x) equals to, let's say x squared minus 1, then our graph will come to minus 1. This is, let's say this is our minus 1, and still our graph will remain same. Say the graph will be like this. Okay, still our graph will remain same, so the shape of the graph will be this one. So in general, now we can say if f(x) equals to x squared plus any number, let's say a, for this number if it is plus, then it will go up the same unit. If it is minus, let me use another color for minus, let's say if it is minus, then it will come down the same number that we have here. So this way we can look at this situation. Okay, let's do some other things which is related to the negative here. Let's look at the negative sign. What about f(x) equals to, if I write f(x) equals to x squared minus x squared. So the minus x squared graph is, for this minus there will be a reflection here. The same graph, this exact same graph will have a reflection here. Then f(x) equals to, if I write x squared minus x squared plus 2. Notice that for the plus 2, graph goes to the 2, so then we will take the graph to the 2, then again the shape of the graph will remain similar, so this will be the graph. This is our plus 2. Then f(x) equals to, what about f(x) equals to minus x squared minus 1, just like this. There's a minus here if we give. What about this? Then the graph will come to the minus 1, and then this shape will be this. So this one, you have not seen that, so see this one is this. So this is our minus 1 is this. So what happens here, for the minus, our graph actually gets the reflection. Okay, and our main formula is x minus h whole square plus k. This formula actually will be used in most of the cases, which is the equation of quadratic function in vertex form. For this number a, any number a, if a is positive, for this a, the graph becomes wider or compressed kind of. Then for this number h and k, they are the vertex. Then if there is a minus here, then it gives reflection. We will discuss this in we have to discuss this more and more, and the main everything is happens for this equation. You will see it in the next page. So let's recap it. What we said is x squared graph, if it is plus 2 normal, then graph will go up. If it is minus, graph will come down. If there is a minus, then graph will have some reflection, and the other things will remain same. For the plus goes up, for the minus goes down. comes down. And notice that there's some extra number. Extra number means there's some outside number. Actually this is k, this is extra number. Now let's look at this. Now let's look at this kind of situation. Say if x equals to, let me use black color for this. If x equals to x squared, if x equals to 2x squared, or let's say if x equals to 3x squared, what about this graph? So what will happen is, if x equal to x squared graph is this one. For this number 2, for this number 3, notice that we are multiplying by some extra number, x squared, and then we are multiplying them by some extra number. That's why our, let's say this is equation 1, this is 2, this is 3, so this is 1. Then for this 2 number, if I use another color, the graph will rise faster. The graph will, because of the extra number, now the value becomes bigger when you multiply it by some positive integer number, then somewhat graph will be like this. Then if it is 3, then graph will move more faster. Like this. So this is 3 number, this is red is 3 number, and this is 2 number. So the graph the shape of the graph will be like this. And what about if we write here now some, let's say some decimal number, then what will happen? 4 number, if x equals to 0. Let's say 0.3 x squared. Then for that, what the graph will look like is, let me try this color if I can. This will be funny actually. So the graph will be like this. The graph is becoming wider, you know, for the decimal. I'm not sure if you can see that color. Maybe I will use some other colors next time. Anyway, so look at this, what is happening here. For this extra number, for this 2, if this value is more than 1, then the graph becomes like this. Graph starts growing first. Then if the number is less than 1, then it becomes like this kind of. Okay, so it becomes wider. Less than 1 means it is 0.2, 0.3, kind of that. The smaller it becomes, the graph becomes more and more wider, kind of. Then, so this is when you multiply by some numbers. Then the same thing will happen if you give some minus. Then the same thing will happen, but it will then get this way, this way, this way, this way. You know, same thing for the negative. Now, another thing is, notice that this, all the points is in the center. Okay, so all of them are in the center, 0, 0, or in the origin. So we should be careful about this also. Now what about this kind of thing? Let's say if x equals to x plus 2 whole square. What about this? Actually what happens is, if it is x plus 2, you just a while back I said the formula is kind of f x equals to a x minus h whole square plus k. This h is actually here now, and for this what will happen is, this for this number there will be some horizontal shift. So, and if it is plus, normally for the plus it should go to the plus 2, but as you can see there is a minus in the formula already. So to balance it, it will go to the -2. So our graph will be like this somewhat. Graph will be like this. That means if it is, this is -2. If it is if +2 is written here, then the graph will go to the -2. Why it happens? Another reason is, look at the coordinate of this point. This is -2 comma this point is -2 comma 0. You can see it this way also. See, the y value is 0. Y value is 0. So when you get 0 here, y is this, fx is y. So when you get y equal to 0 here, see, y equal to 0 you will get when x equal to -2. If x equals to -2, then you will get y equal to 0. That means this will be our vertex at this point. Now the vertex will be this one. This way. So the vertex will be this one. Let me give one more example here. So this is x minus, let's say x minus 1 whole squared. Then the graph will go to the minus, here graph will go to the +1 for the minus, and the shape of the graph will be like this, kind of. Then say if I write here something minus, if I give, then let's do one kind of crazy. Say let's say -2 whole square plus, let's say 1. So what about this one? We can give some number here also. Okay, let me give some number. Let's say some number 5. Okay, what happens? What about this graph now? Now we have to look at this equation, main format of the vertex form. We have to look at that now. Then we have this x, y. We are trying to draw it. Now if we want to draw it, first of all, look at this. What's going on here is, first of all, this is our 1 2 1 2 3 1 2. These are minus, these are also minus. So just look at it step by step. You can just look at this first if you want. So for the +1, our graph should go to the 1, but this is not the end. For the -2, our graph will go to the +2. So +2 is here. Okay, so the graph should go there. Look at this. For the +1, graph will go to the +1, and this is horizontal shift. This number, when it is bracket, this is horizontal shift. Then the graph should go to there. For the -2 is here. Graph will go to the +2. So normally our graph should be we can draw some rough graph, and look at this. There's a minus here. So instead of graph up opening graph, this will be some down opening graph. This will be some down opening graph. So let's say, suppose the graph should be, like this. Let's say graph is like this. Suppose the graph is like this normally, but as there is a 5 here, and you know, for this extra 5, our graph will start growing really faster. So that means the graph becomes like this. It will grow fast, so the graph will, you know, shrink a bit, kind of, if you like to say it this way. So instead of becoming, these are not actual calculation. Actually, we can find out the x-intercept and y-intercept. Then we can put them to get the actual x and y-intercept for this function. Then we actually will get these actual points where it is going through, actually through which it will go through. I mean, to get the x-intercept, you will put y equal to 0, this side 0. Then to get the y-intercept, we will put x equal to 0. Then do the calculation, which we will do in another video, because for that I will make the whole one video, just how to find out exactly through where this point is, what is the coordinate of this point. So the basic shape of the graph will look like this. This is how the transformation work. All right, thank you very much.